let's suppose we have this circuit here, and we have two nodes, node 1 and node 2. So it has two current sources. So the first step is identify the nodes. So we have node 1 and node 2. So we identify the nodes. Second step will be labeling the currents. So let's suppose I label the currents in each branch. Now you have to write KCL equation at each node, Kirchhoff's current law. So according to Kirchhoff's current law, the current entering into node 1 should be equal to current leaving from node 1. So current entering into node 1 is I1 and current leaving from node 1 is I3 and I2. So that means current entering into node 1 is equal to current leaving from node 1. Now, for node 2, write the equation. Current entering into node 2 is I3 and current leaving from node 2 is I5 and I4. So once we have written this KCL equations, next step will be to find out the values of I1, I2, I3, I4, and I5. From here, if we see I1 is going in this direction, so I1 is the current flowing through this branch, so that represents 3 ampere. So I can say that I1 is 3 ampere and I2 is the current flowing through branch 2 and I3 is the current flowing through branch 6. Let's suppose the voltage at node 1 is V1 and voltage at node 2 is V2. So we have to find out what is the current flowing through resistor 2 ohm resistor, that is I2 current. So I2 current will be, as per Ohm's law, that will be voltage drop across resistor 2 ohm divided by resistance. So voltage divided by resistance. So what is the voltage drop? This is ground here. So this is 0 volt. So voltage drop will be voltage at this end of resistor and voltage at this end of the resistor. You need to see the voltages at across the two ends of the resistor. So we will say V1 voltage at this end minus voltage at the other end of resistor divided by the value of resistance, that is 2 ohms. So this gives me V1 divided by 2 as I2. Now for I3, I3 is the current flowing through 6 ohm resistor. So we have to find out I3. I3 will be voltage drop across 6 ohm resistor. That will be considered at, you need to consider this end of resistor and this end of the resistor, both ends of the resistor. So you will notice the direction of current flow. Current flows from higher voltage to lower voltage. So going in the direction of current, we will see V1 minus V2 divided by resistance, that is 6 ohm. That gives you I3. So now plug in the values of I1, I2, I3 in this equation number 1. So I1 is 3 ampere. I3 is V1 minus V2 divided by 6 plus I2 is V1 divided by 2. So we form this equation. Now we will do here the math. 6V1 minus V2 plus this 2 goes here, 3 multiplied here. So 3V1 is equal to 3. That gives me 18. V1 plus 3 V1 give me 4V1 minus V2. So this is the equation that we formed from KCL law for node 1. Now similar steps we will do for node 2. At node 2, what is I3? I3 we already found from here that I3 is V1 minus V2 divided by 6. Now, what is I5? I5 is the current flowing through this branch that represents 12 ampere. Now, what is I4? I4 is the current flowing through 7 ohm resistor. So it goes from this point and goes in the downward direction. The voltage at this point is 0 volts since it is ground. So we will find using Ohm's law, voltage drop across the resistor will be voltage at one end of the resistor minus voltage at other end of the resistor. So that gives me V2 minus 0 divided by voltage divided by the resistance here 7 ohms. That gives me I4. Now you plug in the value of I3, I5 and I4 in this equation number 2. So what is I3? That is V1 minus V2 divided by 6 is equal to 12 plus V2 divided by 7. And now you solve this V1 minus V2 divided by 6, 12 times 7 plus, so you here 12 times 7 gives me 84 plus V2 divided by 7. Then we do V1 minus V2 times 7 is equal to 6 times 84 plus V2. So we got here 7 V1 minus 7 V2 is equal to 6 times 84 gives me 504 plus 6 V2. So from here, I got 7 V1 minus 7 V2 minus 6 V2 is equal to 504. So that gives me 13. 7 V1 minus 13 V2 is equal to 504. So now we form this another equation here. Equation number, we can say that this is equation 3 and this is my equation 4. Now you have to solve equation number 4 and equation number 3. So we will write, I'm writing equation number 4 here. So equation number 4 from here was 18 is equal to 4V1 minus V2. Equation number 3 here is 7V1 minus 13V2 is equal to 504. You need to solve these two equations. So I am using the substitution method. So if I rearrange this equation 4, I will get here V2 is equal to 4V1 minus 18. I will plug in the value of V2 in this equation. So 7V1 minus 13, 4V1 minus 18 is equal to 504. So solve for finding the value of V1 and V2. So now here 13 times 4 gives me 52 V1 minus plus here 13 times 18 gives me 234 is equal to 504. So when you solve this, you get 52 minus 7, 45 minus 45 V1 is equal to 504 minus 234. That gives 504 minus 234 gives me 270 is equal to V1 minus 45. So dividing 270 with 45 gives 6 volt. So we got V1 as minus 6 volt. Once we have find the value of V1, you can plug in the value of V1 in this equation here to find V2. So V2 will be 4 times minus 6 minus 18. So that gives me minus 40 as V2. So we got the voltage at node 1 and node 2 here. So voltage at V1 and V2, we found V1 and V2 from here. Now, if it is required to find the value of I2, I3, I4, that is the current in each branch, you plug in, just simply plug in the value of V1, V2 in I3 equation, in I2 equation, and then in I4 equation. So you can find the value of current in each branch. So this method is called node method.